Bismillahirrahmanirrahim. Covalent bond is one of the chemical bond, and in one of the previous lecture you have already learned about the ionic bond, and in this lecture you will learn about the covalent bonding. So covalent bonding is the sharing of the electrons between the atoms, and this type of the bonding usually occurs between two atoms of the same element or of elements close to each other in the periodic table. Like here, this is the periodic table, and all these are the metals, and these are the metalloid or the semi-metal, and these are the non-metal. So particularly this type of the bonding occurs between the non-metals, and here these are the non-metal. Let's suppose the bond between the Cl and between the oxygen between the nitrogen, and this type of the bond is called the covalent bond. And it may also be observed between the non-metals and the metals, and these let's suppose between the phosphorus and the Cl, because these are the close to each other, and this type of the bonding is called the covalent bonding. Another criteria to evaluate the covalent bond is the difference in the electron activity, and if the difference in electron activity between the two atoms is less than 2, then there is more possibility to form the covalent bond, and if it is more than 2, then there is the possibility to form the ionic bond. Let's suppose in case of the this molecule SCCl3, and the electron activity difference between the chlorine and the carbon is zero point 0.5, which is less than 2, then this type of the bond is the covalent bond. So you can easily differentiate between the covalent and the ionic bond by using this criteria. Let's see different examples of the covalent bond, and particularly all type of the bonds here are due to the unpaired valence electrons. So there must be availability of the unpaired electrons in the valence shells. So let's suppose this is the valence shell, and these two are the paired electrons, and this is having one unpaired electron. Similarly, another atom is having the unpaired electron over here. Then there is the possibility to share the electron by each of these two atoms to form a covalent bond. And it may be a non-metal, and non-metal or the metalloid, as we have discussed in the previous slide. So when the electrons are shared, so this is the nature of the sharing of the valence electrons. Now these two electrons become part of each of the atoms, and they are joined by the bond that is called the covalent bond. So here you will see that the octet of the this atom is complete. That means this atom is having also 8 electrons, and this atom is also having 8 electrons, as we have already discussed to complete the octet in case of the ionic bond. So this criteria you may also fit over here. Starting with a very simple molecule. This is the hydrogen molecule, and each of the hydrogen atom is having only one electron, and one electron is present in the first shell, and the electronic configuration of hydrogen is 1s1. So there is only maximum availability of the two electrons in the first shell. So by sharing one electron by each of the hydrogen atom, so the first shell is complete, and this is the formation of the covalent bond. And this is also one of the example of the non-polar covalent bond, because both atoms are having the same electron activity. So the difference in electron activity is zero. That's why the covalent bond is called the non-polar covalent bond. Another example is the ClCl, that means Cl2 or the chlorine gas. So let's see the electronic configuration of the chlorine atom, and this is the valence shell electronic configuration. The first is 2, and then 8, and then 7. It is given over here. The first shell is having 2 electrons, then the 8 electrons, and then as indicated with the black balls, these are the 7 electrons. And it you may also to have you can also put the electronic configuration in this way. So first 1s2, 2s2, 2p6, and 3s2 and 3p5, because it is having atomic number 17 and proton are 17 and there are 17 electrons. So in the valence shell, there are the 7 electrons are there. So each chlorine atom is having the 7 electron in the valence shell. So complete its octet, each atom needs 1 electron. So 1 electron is shared by each of the atom to form a covalent bond. So when these two atoms share the electron, now the octet of each of the chlorine atom is complete, having 8 electron in the valence shell, and this is indicated over here. Now the electronic configuration is, this is the first shell, this is the second shell, like it is given over here. First is 2, the second shell is 8, and now with the sharing of the electron by each of the chlorine atom, this the valence electrons uh, becomes 8. And you can also see over here, this is 2, 4, 6, 7, 8, and these 2 electrons are shared by each of the chlorine atoms. So octet of each of the chlorine atom is complete, and this is the complete of the octet by sharing of the electron by each of the atom. So that's why this is called the covalent bond. Another example is the Scl molecule. This is also a covalent bond between hydrogen and the Cl. And as hydrogen is having 1 electron, and there are 7 valence electron in case of the chlorine atoms. So chlorine atom needs 1 electron to complete its octet, and similarly, hydrogen atom needs 1 electron to complete its first shell, because there is a maximum possibility uh, to retain the electrons in the first shell is 2. So by sharing of 1 electron by each of the hydrogen atom and the chlorine atom, it form a covalent bond. And after the formation of the covalent bond, or by sharing the electrons, now the octet of chlorine is complete, and the also the first shell of the hydrogen is also complete, and this is called the covalent bond. And here you can say this must be a polar covalent bond, because the electron activity of hydrogen and chlorine is different. Chlorine is having more electron activity as compared to the hydrogen, so this will become electronegative, and similarly the hydrogen will become electropositive. Another example is the oxygen molecule, and here it is the electronic configuration of the oxygen. Oxygen is having the 8 atomic number, so 8 protons are there, and 8 electrons are there. So this is the electronic configuration of the oxygen. In the first shell, there are the 1s2. So you may see over here, there are the two electron in the first shell, and then in the second shell, there are the six electrons are there, 2, 4, 5, and 6. And you may also see over here, these are the six electron, 2, 4, 5, and 6. So these are the six electron, 2, 4, 5, and 6. So these electrons are going to be shared by the each of the oxygen atoms, because there are two unpaired electrons are over here, or you may say there is the possibility of gaining the two electrons of each of the oxygen atoms from the another oxygen atom, so that they should complete its octet. So here 2, 4, 5, 6 electrons are there. So to complete its octet, it needs two more electron. So each of the oxygen atom is sharing two electrons. So two electrons are shared by each of the oxygen atom. So there is the formation of the double bond, because each bond is the sharing of the one electron. So and here there is a sharing of the one electron from each of the oxygen. It form a single bond, and then there is a sharing of the electrons from another electron from each of the oxygen atom. Then there is the formation of the second bond. So this we call it is the double bond between the oxygen molecule, because it needs two electron to complete its octet. Another example is the water molecule, and here again, oxygen is having the six valence electrons. It needs two electron to complete its octet, and there is another possibility uh, to form a two bonds between the oxygen and the two hydrogen, because each hydrogen is sharing one electrons with the oxygen. So with the sharing of one electron with the oxygen, it forms a two bond between the oxygen and the hydrogen. And these two bonds are called the covalent bonds. And here this is also example of the polar covalent bond, because the difference in electron activity between oxygen and the hydrogen, and the electron activity of the oxygen is more as compared to the hydrogen. That's why the attraction of the electrons, the shared electron is more towards the oxygen. That's why it will become electronegative, because the electron is having the negative charge. And similarly, the other one, which is the hydrogen atom, it will become electropositive. That means having the deficiency of the electrons. Another example is the PCl3, and here is the phosphorus, and these are the three chlorine, and each the phosphorus is having the five electron in its outermost shell, and this chlorine is having the seven valence electrons. Each chlorine needs one electron to complete its octet, and similarly, the phosphorus needs three more electrons to complete its octet. So that's why phosphorus is shared it's one unpaired electron with the one of the chlorine atom, and similarly one electron is shared with the another chlorine atom, and the third electron is shared with the another chlorine atom. So there is the sharing of the electrons of the phosphorus between the chlorine, and this is the completion of the octet of each of the chlorine atom as well as the phosphorus. And here there are the eight electrons in the valence shell of the phosphorus and the chlorine atoms after sharing of electrons between them. And that's why all these three bond are called the covalent bond. and these bonds should also be a polar in nature because the both atoms are different and they are having the difference in electron negativity. The last example is the nitrogen. Sorry, this is the nitrogen molecule, and the atomic number of nitrogen is 7, having 7 protons and the 7 electrons. So this is the electronic configuration: 1s2, 2s2, 2p3, and in the valence shell there are the 5 electrons. So each these are the two are the paired electrons, these are given over here, and there are three unpaired electrons, and to complete the octet of one nitrogen it needs three more electrons, and similarly this another nitrogen needs three more electrons to complete its octet. So each nitrogen atom is sharing their three electrons with the three electron of another nitrogen atom. So this will form the triple bond over here because one bond, second, and the third bond. So because each bond is the sharing of one electron from each of the nitrogen atom, and here you can also visualize. So these are the actually 2, 3, 4, 5 are the valence electrons of one nitrogen, and similarly 2, 3, 4, 5 are the valence electron or the another nitrogen atom. So with the sharing of the electrons, now these are the 6, 7, 8. So octet of this nitrogen is complete, and similarly these are the 6 electrons, 7 and 8. The octet of another nitrogen molecule, nitrogen atom is complete, and this is the formation of the nitrogen molecule by sharing of the three electron by each of the nitrogen atoms. That's why it will form the triple bond, and each bond is the covalent bond. So this is all about our today lecture.